You.
My network is slow. I can't hear you.
Your network is slow. Why?
So
Why?
I'm traveling, sir, actually.
You are traveling. So when you will settle down? If you will be
No,
traveling, then
I'm now in a related house, but the net is bad, sir.
your internet is bad. Okay, so
Yes.
my screen is visible to everyone. We already covered these topics, right?
Yes.
We already covered these topics. What next? Anyone can guess? Any guess what could be the next topic?
Excuse me, second region.
We already discussed about the Ohm's law, dependence of resistance or over length and its cross-sectional area. We define the potential and potential differences. We calculated some numericals uh, based on Ohm's law and resistances, right? Do you remember? We calculated all these numericals. Let me on the video so you can see me. Jaslyn, sir, can I join? Why not? Everyone can join. Who is this? Ridwan. Yeah, Ridwan, you are already in. So, Jaslyn, do you remember what we studied last time? Madiha? Jaslyn, Madiha, and Rizwan. Do you remember we studied all these numericals last time? And what about your assignments? Did you solve it?
Yes, sir.
Do you have any problems in your assignments? Any doubt?
No, sir.
No. Your network is just stable? Is your network stable? Madiha and Jaslyn. Rizwan was traveling, so he left the class.
Yes, sir.
Okay. So you are feeling low? There is.
No, sir.
Okay, good. So if only my video is on, then I should minimize it. So did you solve this question last time?
Yes, sir. We finished.
We finished. Okay, so let me change the pen size. This size is okay. This size is okay. So we are proceeding, and this is the resistance of a system of resistors. So we already know that we can connect resistors in two ways. One is series combination and another is parallel combination, right? So before proceeding, which type of connections are in our houses and which type of connection, series or parallel, are in our houses? In our houses, which type of resistors or load are being connected? These bulbs and fans in our house are is series combination or in parallel combination? Tell me, Madia. In our houses, the fans, bulbs, tube lights are connected in series or parallel. Do you know anything?
Parallel.
In parallel, yes, right. So if it is connected in series or parallel, what will be the differences? What will be the differences? If these connection are in parallel or series, what could happen? See, in parallel, as you said, this is one load. Suppose this is our 220-volt supply. Okay, and we will write it like this because we are getting variable current. So this is, suppose this load corresponds to fan. Who is new? Anyone entered in the class? We have Zeba. Zeba. Zeba is your first class? Zeba is your first class?
No, sir, it's my second class.
Your second class. In last class, we have studied about Ohm's law, right? Dependent of resistance on length and area of cross section. Yes?
Yes, sir.
Okay, so did you solve the assignment?
No, sir, actually, I was traveling, so I didn't.
Okay, so you didn't see the assignment as well, right?
Yes, sir.
Okay, so do it and submit it as soon as possible. So now, today we're gonna study about the combination of resistance. Resistance means that combination of loads. If we say that resistance, we means that this is one of the fan. I'm just saying about the parallel combination. Okay, what is the parallel combination? Is my writing readable to everyone? Is my writing is communicatable? Can you read my writing? By the way.
Yes, sir.
Okay.
So what you wrote after parallel?
Parallel combination.
Okay, sir. Sir, I'm Ridwan. Okay, sir. I
Okay.
joined with another device.
Okay, so you are professor for the day.
Yes.
So in parallel, see, this is fan. It is connected to a potential of 220 volts. Okay. So again, if we wanna put another bulb, so it is again connected with this is a bulb, PULB bulb. So again, it is connected with 220 volt across the 220 volt. So we are adding n number of devices, and each are having equal potential difference. Okay, current may be distributed. How current is being distributed, we will see it. Okay, so if I'm doing, let me rub some space and then do it. So I'm talking about the parallel combination because we come to know that in our homes, all appliances are connected in a parallel. So this is two load, one fan and one bulb, right? One bulb. This is connected to a 220 volt supply. 220 volt supply. And this is symbol of variable current. Okay, if it will DC, then we must have the battery sign. This is our fan. This is our bulb. So potential across these two terminals is 220 volt, but the current will be distributed. Okay. Current will be according to their requirement or something. So this will be I1, this will be I2. So this current is I. Then in case in parallel combination, current will be distributed, but potential will remain same. So all the appliance will work with full capacity. Got the point?
Yes, sir.
Okay, so this is what the reason that in our homes all appliances are in the parallel combination. Good? Clear? So moving on further, we have,
Sir, I have a doubt.
yes.
Sir, in the right side, you drawed one diagram, right?
Yes.
And it says 220 volt, right?
Mm-hmm.
What if it is 240 volt?
240 volt. So see, our appliance can withheld with 220 volt only. Okay. If you will eat more than your daily requirement, what will happen? It will blast.
No, but I once saw in a house that they like used 240 volt.
240 volt. So
But
in that case, bulb having rating 240 volt only. Bulb should have rating of 240 volt. Otherwise, it will burn. Okay. Did you
okay,
get
sir.
my point?
Yes, sir.
Did you get my point or not? If we have a
Yes.
12 volt bulb, 12 volt bulb, okay, and we are connecting it with this is 12 volt. Okay, the 12 volt bulb, we used to play with it. Okay, or the torch bulb. Torch bulb is 1.5 volt bulb. If you will see, you will find the rating. If you will connect it with 12 volt battery, what will happen? If it's 12 volt battery, what will happen? The bulb will burn, right? Or not? Tell
Yes,
me.
sir.
It is well understood that the power rating on the bulb and the supply should be in order. Otherwise, your device will get burned. We see most of the time our devices get burns, especially in the night time. When you will wake up, you will find that the bulb is being, nowadays it's LED bulb, so it's hardly fused. But when it were the gas type bulb, neon bulb, the blue one, so it usually has uh, fuse, get fused when the power supply in the night time increases. Because in night time there is less load, so power supply increases. The potential drop increases. So most of the time in the night, you might have seen that bulb got fuses when you got up in the morning. You got that? So again, if you will come to India, you will see in Indian railways, they use 110 volt supply, DC supply. Okay, 110 volt DC supply. DC supply. So to run these bulb, you need 110 DC power. If you will connect it into 220 volt with our apparatus, the supply we are getting in our home, the bulb or fan will get burned. Okay, this is the situation. So it's clear now why, what the parallel combination and what is it use. Madhya, Jaslene, it's clear what is parallel
Yes, sir.
combination, what is it use. So we get the maximum potential when we connect our operators in parallel way, right? So another combination is series combination. So I will give you little brief what is series combination. And then we will drive the relation for the uh, combination of resistance. In series, what we do in series combination, this is suppose a bulb, this is a fan. Okay, this is connected with a variable power supply like this. So in this case, current will remain same. In series, current will remain same. But what will be if it is a fan? Okay, so it will drop some potential. Okay, if the in this terminal it is V0, so the potential will be dropped. You have noticed that when you connect a heavy iron, cloth iron, or when you switch on the washing machine, you might have seen some fluctuation in lights. Have you? Have you seen that? Have you experienced that thing? When you switch on the heavy gazette, then you might have seen some fluctuation in circuit or bulb. You didn't? Uh, this happens. So you guys have less experience of our daily life. That's not a good thing. So it's fan. So the potential will be dropped across it. Again, you will add a bulb. So again, there will be some potential drops. These potential drop, if you will add n number of operators, n number of, suppose 10 or 20 operators. So reaching at the last operators, you will find that that is very slow or very dim, right? So in this case, like the same as in the twinkling light being used at the marriages or something. So one demerit is that you will lose the capacity, and another is that in this circuit, if it is connected like this, n number of resistances over there or load. So if one get burned, the power supply will disrupted. Got the point? In
So
parallel
you're talking about
combination.
fuse.
Sorry.
So you're. So I got disconnected. Can you repeat what you said?
Okay, I'm saying that in series combination, if we have n number of loads, n number of bulbs or fan or some electric gadgets are being connected. So suppose that one apparatus got defects or got burned, then the supply across this terminals will stop. Okay, so you won't get any supply. This is one of the demerit of series combination. Got the point?
Yes.
Now we will see in detail what is series and what is parallel. So this is one of the circuit. This is resistor in series. Got my point? So we see
Yes.
that this is connected with the power supply. This is connected with the power supply. This is key, and the current is flowing from this direction, from positive terminal. It is going from positive terminal and coming back to a negative terminal. This apparatus is called ampere meter. Okay, this is a meter, ampere meter. This ampere meter is being connected from one end to another end. This is two end device. We already studied what is ampere meter when we were dealing with concept. So we see that this is positive terminal and this is positive. So it is connected over here. Negative terminal is connected over here. How the voltmeter is connected? Voltmeter is connected across all these resistors R1, R2, R3. This is this knob. There is a dot in between this circle, semicircle. So it means that circuit is closed, right? So first thing that in series combination, in series combination, the current I remains same. Got my point? If it is 5 ampere, it will remain 5 across the resistors. That was okay. But what will happen? The second thing is that potential difference will be varying. Potential difference, POTEN, potential will change. Current will remain same, but potential will change, right? So if we have a potential V naught over here, or we say VA, here it will be VB, here it will be VC, here it will be VT. Okay, got the point? So what I say that the current I will remain same and potential will change. This what mean in series combination. So across these all terminal, if this is contained at V, so V will be equal to across this R1, if there is V1 drop, across R2 there is V2 drop, across R3 there is V3 drop. So this will be sum of V1 plus V2 plus V3, right? Is this clear? Can we go with this idea? Can we go with this idea? Rizwan is really struggling with his network. Madiha, Jaslyn, and Zeba.
Yes, sir.
Is clear till this point?
Yes, sir.
Jaslyn, we hardly listening you today. Jaslyn, respond. Is clear to you? Is clear to you? Okay, Madiha and Zeba, we are moving further. So see, we know that the resistance across V1 is R1 and current is I. So what it will be? V1 will be, current is I, it is not changing, and resistance is R1, right? Similarly, what will be the value of V2 in terms of current and resistance? Anyone? Go ahead, tell me. Tell me what will be the potential drop across resistance R2. This is also called the potential drop across resistance R1 for the current I. So the same thing, will you tell me what is the potential drop? Rizwan, are you back? Yeah. So I was saying that we know already that potential will be changing. So if some potential is drop over here, that is V1. Okay. Some potential is drop over resistance R2, that is V2. And some is V3. So if we will add all V1, V2, V3, it will be equal to the equivalent resistance of the circuit, right? If we will add all the drop, it will equal to the total resistance of the circuit. Is clear or not?
Yes, sir.
Okay. So now what will be the potential drop across this resistance? It is current time resistance, right? Is clear? So now I'm asking what will be the potential drop across the resistance 2? What is the potential drop across the resistor 2? Will you tell me? Zeba, will you tell me what will be the potential drop for across the resistance R2? No, either you have to ask me or you have to tell me, then only I will proceed. Otherwise, I will be waiting for your response. So this part is clear or not? This part is clear to everyone? Respond. Unmute your mics. Jaslin, Zeba, Ridwan, all. Unmute your mics. No
Yes,
need
sir.
to mute it. Unmute. Zeba, unmute it. Okay, she's left. She can't do that, but she prefer to leave the class. Jaslin, unmute the class. Unmute the mic. Madhya, unmute the mic. I need your responses. Ridwan, this line is clear. The equation number 1 is clear to you.
Yes, sir.
Okay. We have added all the drops that must be equal to the V total. Jaslin, unmute your mic. Madhya, unmute your mic. Okay. So equation first is clear to everyone.
Yes, sir.
Jaslin and Madhya. This equation V1 is equal to I R1 is equal to everyone, clear to everyone. We already read this this relation in Ohm's law. This is the Ohm's law. We already discussed. So this says that the potential drop across R1 is current time the resistance. Clear? Yes, sir. Jaslin, yes, sir. Okay. So
Yes, sir.
now I'm asking what will be the potential drop across the resistor R2. Tell me.
You mean V2?
Yes.
Uh, mm,
Madhya and Jaslin, I told to unmute the mic. You guys are not responding. You are just
I
sitting.
R2.
I
R2.
R right.
R2.
Good. What about V3? Madhya, what about V3? I'm asking to Madhya only. Madhya, the first and this equation and this equation is clear to you? Or Jaslin?
Yes.
Okay, then tell me, Madhya, what will be the potential drop across the resistor R3?
IR3.
I R3, why?
Because it's same.
Because it's same. I don't know in which sense you are saying same, but the potential drop across the resistor R3 will be the current time the resistance. Okay. I already said that current remains same. I remains same. I is I over here. I will be here the same. Okay. Here it will be the same. Here it will be the same. I won't change. What will change? Only the potential will change. So in this way, we got all three potential drops, right? So after using all these relation, we already know that V is equal to V1 plus V2 plus V3. We are only considering three resistance, okay? Combination of three resistance. So we already know from Ohm's law, if it is V total across this terminal, across this point to this point, this battery is applying the V volt. So, and the resistance of all the circuit is R1 plus R2 plus R3 is equal to something. So if it is equal to total current I and R, and this V1 is equal to I R1 and V2 is equal to I R2 plus V3 is equal to I R3. We can write it like this. In the next line, I may take I common and we'll say R1 plus R2 plus R3. No harm. We can do this. Jaslyn, we can do this. Jaslyn, can we do this? Is this calculation permissible? Okay, Jaslyn has responded, yes, sir. So what will we do next step? This equation, this side, and this equation, this side. What we gonna do now? Madhya, what could we do now? Zeva, what will we do? What's the way to solve this equation? Respond. See, I will do in 1 minute, okay, even the fraction of minutes. But why I'm asking your responses, that's better. Okay, if what happened? Something happened from my side. My screen went off, I think. Okay, it's back. Maybe some update. So, Zeva, tell me how we will solve this equation. Ridwan, Madiha, Zeba. How we will solve this equation? You got? We added all the potential drops, okay? Because the some potential drop across R1, R2, R3. If we will sum all, we will get the original one. That happens now. If we have 10 rupees, we purchase 2 rupees biscuit, 3 rupees banana, and 5 rupees something else. If we'll add 3, 5 plus 3, 5 plus 2, it will sum to 8. Sorry, 10. So in the same way, we drop V1, V2, V3, we will add, it will be V. So we added all and then substitute the value of V1, V2, V3. And we got this relation. How we will solve it further? This is my question from Madiha and Zeba. Madiha and Zeba, tell me how we will further solve this equation.
I don't know.
This is I, R, and I time R1 plus R2 plus R3. Okay. So Zeba, how we will do?
I don't
Madiha,
know.
Madiha, you know? She may be knowing, but she is somewhere else. So see, if we have 2 into 3 is equal to 5 into 2. How we will do it? This 2 from left side and this 2 from right side will be cancelled, right? We will get 3 is equal to 5. Like that. Like that. Okay? This is the way
Then
we do. Sorry?
we can cancel I.
Yeah, this is not the right equation, but I only given for example. So I'm going to first cross it. Okay, otherwise you guys will be confused. So this I from this side, this I from this side will be cancelled. Okay. So now you will get R net. This will be equal to R1 plus R2 plus R3. This is for 3 resistance. THRW 3 RESISTANCS resistance. For 3 resistance R1, R2, and R3, right? If we have n number of resistors, see, if we have a combination like R1, R2, R3, R4, and dot Rn. It is being connected with a source of total potential V. This is the current I. This is R1. This cross V1. This, this is R2. Potential drop across this is V2. This is R3. Potential drop across is V3. R4. Potential drop across is V4. And this is Rn and potential drop across Vn. So if we want to write R net, R total or R net, we can write it R1 plus R2 plus R3 plus dot 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 Rn, right? This is true for n number of resistors, not only for 1 or 2, 3, 4. It is true for if when we have millions of connections in series. This is the way. This calculation is clear to everyone.
Yes, sir.
Madiha, Jaslyn, and Zeba. What is your
Yes, sir.
Jaslyn? You just message me. Madiha. See if you want, respond how I will guess or figure it out that you got the point or not. So it's better you respond. Okay, no problem. You keep your mic on. Your privacy is always being respected over here. Okay, so don't worry. You keep your mic on and attend the class. Respond well. Otherwise, it will be tough. Now we have this problem for you. If you got the concept, it could be done easily. Do it. The electric lamp whose resistance is 2 ohm. This is the electric lamp whose resistance is given 2 ohm. And a conductor of 4 ohm. This is already given here. Are connected to a battery of 6 volt. Calculate A, the total resistance, and B, the current through the circuit. Okay. And C, the potential differences across the electric lamp and the conductor. So we have 3 questions. Do one by one. Hope you will do it. Rizwan,
Yes,
it
sir.
is solvable. Are you still traveling?
Yeah, yes, sir. I'm in a relative's house.
Okay, so now you are stable. Okay. So do you
No,
have
I
pen
was
paper with
net.
you?
Yes, sir. I bought.
No, you borrowed. Okay. Or you have your own.
Sir,
So
but my net is not stable.
your net is not stable, but this figure and question is clear.
Yes, sir.
Okay, then do it fast or take the screenshot and then solve and then share the answers. The same way,
Okay, sir.
Zeba, Madiha, Jasmine, unless until you won't solve, I won't proceed. Don't think I will solve it for you. You do it and show me. If Ridwan will solve me, I will solve for him. If you won't solve, I won't do it.
Sir, what's the name of that symbol, sir? That after 20.
Mm, of an electric lamp whose resistance is 2 ohm and a conductor of
Oh,
4
oh,
ohm resistance are connected to a 6 volt battery as shown in figure. Calculate A, the total resistance of the circuit, B, the current through the circuit, and C, the potential differences across the electric lamp and the conductor each. First, we have to calculate the total resistance of the circuit.
sir, but, uh, will it be 24 ohm? First
Of
one.
course, of course. Now we need responses from Jaslin, Madiha, and Zeba. What will be the answer for A? If Madiha, Zeba, and Jaslin won't respond, then I will come to the PTM meeting. Madiha, did you get the answer?
Yes, sir. 24.
24. So you have to say na. So what about Jaslin? What is your answer? For A, see R will be equal to R across that electric bulb. I am writing it electric lamp E L electric lamp plus the another one is conductor, then R conductor. Okay, conductor. So for one is 20 ohm and for another is 4 ohm. So it is 24 ohm. Right? The question number B. What is the answer for the question number B? Jasleen, what is answer for B? What is solution for B? The current through the circuit. Okay. What is current through? I'm not sure. So the first question is, did you understand the first calculation? 0.25. 0.25, yes, of course, 0.25 is the right answer. 0.25 is the right answer. So how we will do? Current. Current is V is equal to IR. Okay. So I is the current, so we will solve it. I will be over to V over R. So V is how much? V is 6 and R is 24. Wow. One, this is now turns out to be 0.25 ampere. This was the answer from Jaslyn. Okay, so this was the answer from Jaslyn. So we got the answer for question B. What about the C? What about the C part?
Sir, sir, again got disconnected. Can you repeat what were you saying?
So I'm asking again. We got the B part. That is what is the current through the circuit. So it means that the current through the circuit will be 0.25 ampere, right? We
Yes.
sometimes write is with capital A. So we got this current, or we got resistance, total resistance of the circuit as well. So the next question is, what will be the individual potential drops? So it says that electric lamps, it's 5 volt from Jaslyn. So electric lamp, then V electric lamp will be total circuit, sorry, total current through the circuit will remain same. So it will be 2.25 and the resistance across the electric lamp. So I is 0.25 and REL electric lamp is, sorry, 20 ohm, right? So
Yes.
the resistance is 20 ohm. So we will just write it 20 and we'll do the sum. So let me create some space. So I know that we can write is 25 over 100. and then 20. So it will be 5 times and this will be 4 times, 5 times again. So this is 5 volt. So this was the answer from Jaslyn, I think, right? Jaslyn,
Yes.
5 volt. Yeah, Jaslyn. So now, Madiha, you calculate for the conductor. What is the potential drop across the conductor? This one, what's your answer? Zeba
Which
left the
one?
class. Sorry?
Which one, sir?
The potential drop across electric bulb was 5 volt in your case or different?
Yes, sir. The same, sir.
What about Madiha? It was same or different? Madiha, it was same for you or it was different?
Sir, same.
Okay, how you solve that? That's the point. I wanna see that as well.
V1 is equal to IR1 is
Okay,
equal to
that's good.
0.25A into 20.
Okay, 20. What about the second part? Solve it. C, second part of C, the across the conductor. Jaslyn already forwarded her answer, I think. Uh, yes, she says
Sir, I got
what? What's your numerical
we should multiply 0.25 into 4, right?
0.25 into 4. Yeah. So V across conductor, we are writing is VCON conductor. That is, I will remain the same and the resistance will be 4 ohm R across the conductor. So let me create some space to do further calculation. So this is already 0.25 into 4. So this is nothing but 1 volt, right?
Yeah, yes, sir.
So in this way, we completed this numerical. So concept is clear to Jaslyn and Ridwan. This calculation is clear. Will you write it down
Yes, sir.
or you take the screenshot? Okay,
Done, sir. Done, sir.
done. Any doubt, any confusion, any suggestion, any feedback?
Yes, sir.
No. It's not that much perfect that you got everything. No one is perfect. You might be having some doubt, some issues with calculation. If it's 110%, then good. Understood, sir. Okay. Then wait for the next assignments. I will be sending you assignments right on. And next day, I thought of covering all series in parallel today, but we couldn't do that. So maybe next class we will be doing parallel combination. Okay, no issue.
So, like how?
We did this. We did this series combination. Okay, next time we will be doing parallel combination. Okay. We already discussed what
Okay.
is series and parallel. Okay, what is its use?